All right, welcome everyone. In this lesson, we're going to see how to calculate the derivative of the quotient of two functions. So kind of like what we did for product rule, we're going to first introduce the rule. We call it quotient rule. And then we'll go through just a bunch of examples just to kind of get practice, first identifying when we need to use the rule, and then actually implementing this new quotient rule that we're going to be looking at it. So let's start with, what does the rule actually say? How do we actually differentiate the quotient of two functions? So let's read through what the quotient rule is. It says the derivative of the quotient capital F of x divided by capital S of x. So we have the quotient here of two functions and we want to do the derivative. Well, how we actually calculate it is with this formula. So it's the derivative of the top function times the second function minus, or times the bottom function, minus the top function times the derivative of that bottom function, all over the bottom function squared. So this one's definitely a little bit more involved than the other rules we've seen. We've seen the sum rule, that one's very nice. The constant multiple rule, also very nice. Product rule, not too bad, a little bit extra work, a little bit not quite what we'd expect, but still not too bad. Quotient rule, there's definitely more going on here. So there's various ways you can kind of memorize this formula. You can just memorize it. We'll go through a few different ways to help you remember what the formula says. But really, first thing that's important is to recognize when you need to use this. And so we're going to use this when we have a quotient of two functions. And you want to be able to recognize, where does this happen? And normally it's when we see a fraction, when we see division. So if you see a fraction, a lot of times, not always, we need, it's hard to read, fraction. A lot of times it's going to be necessary if we have a fraction to use the quotient rule, but there are cases where it's not necessary, and we'll look at those too. All right, so let's kind of start with a warning, kind of like what we mentioned for the product rule as well. So just a note here. So if we wanted to differentiate a fraction like this, a quotient, it's not what we'd expect. So you can see there's a whole bunch more going on here. It's not quite what we'd expect. So normally what we'd probably think, and it's seemingly very plausible, if we wanted to differentiate this fraction, what would you do? Well, you just differentiate the term on the top, and you differentiate the term on the bottom, and that would be it. So you just differentiate the top function, differentiate the bottom function, and that's it. And very plausible, very tempting, but unfortunately, it just doesn't work out that way. So, no. Capital letters, exclamation point. Doesn't work this way. Unfortunately, wrong. Very tempting, but it just doesn't work out. So instead, we have this nicely more complicated formula to use. So how can we actually remember this? Well, I'll go through a couple of the ways that I remember this. So let's say we wanted to differentiate a function f of s divided by, or f of x divided by s of x. Want to differentiate this whole thing. And we kind of implemented almost like we were going to do product rule. So you can kind of see some remnants of a product rule happening up here. And that's kind of along the same ways you might want to remember this. So what we can do is we can write down we can write this quotient as a product. So top function times the bottom function. And then just like we did with the product rule, we just do 2 copies of this. So top function times the bottom function in that order. And just like we did with product rule, in the first copy we apply the derivative to just the first term. In the second copy we apply the derivative to just the second term. Now the only difference here is we put a minus in between instead of an addition sign. And then we draw a nice big fraction and we square the original denominator. So whatever our denominator was, we square it. We don't do anything to it other than just squaring it. So this is one way to kind of help remember the quotient rule. It has its roots in the product rule, so you can kind of see that in what's happening with the numerator. So numerator is similar to product rule. Not quite. It's a little different. So we have that minus instead of a plus. And if we were doing this, when we kind of rewrite our quotient as a product, the top function comes first and then the bottom function comes second. All right. Now that's one way to remember this. The other way is with a little rhyme, and I still remember, still kind of play this in my head too. So if you kind of see me nodding along, I'm thinking of this little rhyme. I don't have my singing voice today, so we'll just kind of we'll kind of just talk through the rhyme here. But how it goes is another way to remember this formula is low D high minus high D low. And then draw the line and you square the low. So that's another way to kind of remember what's going on here. So it's the bottom function times the derivative of the top minus the top function times the derivative of the bottom. And then you have a big fraction, and then you square the bottom function. You square the term that's in the denominator. So low D high minus high D low, draw the line, square the low. So another way to remember the quotient rule. So lots of different ways. Pick one that works for you, and that's fine. All right, so in the next video, we're just going to see some examples of actually going through and calculating this quotient rule. So we'll see you there.